It's all about science. Join me, Dr K, my sidekick Nash, and our very own superhero, Eureka Girl, as we explore superpowers such as...
You read my mind. Come on.
Air manipulation, spider powers,
Whoa.
super strength,
How did you do that?
cryokinesis, and many more in our brand new series, Make Me a Super.
Boom. That was awesome.
In today's episode, I become damsel in distress, and it's all up to Dr K and a little not so creepy crawly to swing to my rescue. Who knows? Maybe we'll get to become web slingers or something. But first, a visit to the Lee Kong Chiang Natural History Museum to get our spidey senses tingling.
Nothing like a trip to the museum.
My treat, they've got all kinds of specimens in here. Birds, mammals, crabs.
And spiders look like those.
Why on this good earth would anyone want to even... I mean, look at that. Why would anyone even... Okay. Get it off! Get it off!
Too funny.
Hey, you know I'm afraid of spiders.
Arachnophobia, that's a rat.
And besides, this is a museum. Show some respect.
At least it was a bit funny, right?
Thanks, EG. Now that was funny.
No problem. I was just checking on my powers after being bitten by a radioactive spider.
Were you really bitten or did you get a spider to bite you?
Does it matter? I'm a cartoon, so it's probably not even a real spider anyway.
You can't explain things away just like that. We don't have that privilege.
Well, I'm off to save the world. It's a web of shadows out there, and it's up to me to unravel it, one thread at a time.
Really? Webs of shadows? Thread.
Woohoo!
There she goes again. Actually, it'd be pretty cool to have Spider-Man's powers like EG, just as long as they don't look like one. Ew, look at that one. It's so big and his legs are so long and hairy.
That's a tarantula, one of the biggest spiders in the world.
And look at that one, the golden web spider. It can spin webs up to 2 meters.
Come on. No matter how gross they look, I actually love being able to shoot webs, climb walls, swing from building to building.
But is that really possible though? I mean, we're much bigger than spiders, which also means we're much, much heavier.
The bigger we are, the heavier we get. That's why our hands can't hold up a wall like a spider can.
That has to do with the concept of velometry. Basically, animals and plants behave differently because of their different sizes.
That's how an ant has relatively small feet compared to a dinosaur. Look at those bones!
Whoa, cool. So if we wanted to have these powers, we need to be really small like a spider?
I think I know where to go.
Hey, wait up! Don't go alone! It's dangerous! Hey!
And so, we arrive at the Singapore University of Technology and Design
1, 2, 3, take another look at me, don't you
to meet a genius inspired by nature, Dr. Mohan Rajesh Ilara, a talented expert who has dealt with all kinds of robotics, ranging from navigation, control, to even human-robot interaction.
No! No! Just calm! Just calm. I'm scared. I'm scared. I don't like spiders. I don't like... Look, spider! Ow! Okay.
Where?
You lied to me. Oh, hello.
What? Is that a spider?
I guess so.
It's kind of not creepy.
Yeah. And it's a four-legged one.
I mean, they're actually wires, but...
I see, you met Scorpio.
Oh, hi, Prof. Mohan. Nice to meet you. I'm Nash. She's Dr. K.
Hi, Prof. Mohan.
Good to see you.
You too. This Scorpio is really cool. It's like a spider's transformers thing.
Robot. Anyways, how do you come across this idea?
Scorpio is developed at the Temasek lab at SUTD and with prospective applications in urban reconnaissance and security missions. The inspiration for Scorpio is from Sebrenus reichenbergii, a member of the huntsman spider family. And Sebrenus reichenbergii is a recent discovery, only found in the deserts of Morocco. The spider achieves rolling, crawling, as well as climbing wall surfaces.
Whoa! I didn't know spiders could move like that.
Well, reality is a lot cooler than you think.
Can I try it?
Yes, of course. Here are the controls.
So, how do I navigate Scorpio?
So the buttons on the left you see allows you to control the crawling gaits of the robot, whereas the one on right allows you to achieve rolling and of course to control the rolling gaits.
Can I try it?
Yes, of course. Here
I
you
want
go.
to try. I want to try first.
It's my turn.
No, it's my turn.
I'm first.
No.
This time I'm first.
Ooh, awesome.
Whoa!
Stop.
Whoa, look at what it's doing! It's like, kind of like...
Okay,
Do you know what you're doing?
This might take a while.
My turn. My
No,
turn. My
you
turn.
had your turn.
Fine, make it come back here.
Yeah, making it go. See?
Is it coming back?
Yes, it's coming. Yes, it's back. It's coming. It's almost there. It's going to finish. It's going to cross the finishing line. It's going to cross the finishing line. Almost there. Yay! Woo! Yes! Yeah, we did.
Would you like to see it in action?
Yes!
I can only be saved by one. Scorpio. Scorpio have one mission. Deliver the Ring of Destiny and save me from this evil writer. And down it goes on that steep slope. No terrain is too tough for this little guy. Not even a bend on the road. Navigating its way through a dark tunnel. Look at it scale that wall. Time is running out.
Whoa, it's making a turn! Woohoo!
Will he reach me in time? I hope he does. Please do.
You're almost there, Nash! Get the ring!
Hello there.
Nash!
I got the ring.
Woohoo! Down, evil writer!
Justice is served.
Whoa! That was super
I
cool!
know, and I got the ring.
I'm glad you had fun.
So how does that exactly work? Is it like Spider-Man where he uses his hands and legs to climb out the wall?
Or does it use Velcro?
No, Scorpio uses a closed-link biped mechanism with microsuction tapes in its belly and legs to achieve wall crawling. In addition to that, it uses its legs to achieve better stability and also to realize any rotational or orientational changes.
So, if we wanted to scale walls, we'll have to use our bellies.
That's not what I imagine Spider-Man would do. Climbing up the wall with his belly.
Spiders have evolved over millions of years to have skin structure that has natural microsuction cups. If we need to crawl up wall surfaces, we have to develop artificial skin so that we can wear them on and climb over wall surface.
So it's possible for us humans to actually climb out walls?
Yes, it's technically possible.
So, what's in the future of Scorpio?
So as you can see, we have been working hard to reduce the size of the Scorpio platform over the years. And secondly, we are looking to use Scorpio as a projectile so that it can be thrown into a building, like in a case of an urban reconnaissance mission. And lastly, we are looking to extend the lifetime of the robot.
Wow. Thank you so much, Prof. Mohan, for sharing with us such wonderful technology.
Yeah, thank you so much, Prof. Mohan, for showing us this
No problem.
Scorpio.
Can I have another spin?
Yes, of course.
Okay, I'm gonna go too.
Where's the control?
Wait,
thingy?
where's the control?
Up next.
Whoa!
That's pretty strong for what was just very thin fiber.
See, spiders on their bed, right?
Very different, Nash. That was a robotic spider. I don't think I want to see a real spider anytime soon.
Real spider or not, we haven't explored some of Spider-Man's powers.
Well, I guess not. Scorpio could climb up walls, crawl along surfaces, even roll, but it does not have spider silk.
Yes, spider silk is one of the most amazing things in the world.
Yeah, it can be used to make webs, trap prey, travel from place to place.
And even save a spider from falling.
And all that despite being so thin.
Yeah, even at human size, it's still about the width of thread.
That's definitely too weak for us, right?
Maybe there are some stronger alternatives.
Yeah, where are you going with this?
Let's keep this a surprise, shall we?
Wait, a surprise? Hey, I don't like surprise, Nash! I hope he's not gonna take me to see a real spider.
With that, our adventures have led us to DSO National Laboratories, Singapore's largest R&D organization, where we meet Janelle Chua and Yap Jing Han. This young duo might just know many a thing or two about spinning a web strong enough to hold me, or maybe even more.
Hi Jing Han, hi Janelle.
Hello.
Hey Nash, and you are?
There aren't actually any spiders here, are there?
No, there aren't, I promise. Come.
Sorry. Hi, I'm Dr K. There really aren't any spiders here, right?
Nope, no spiders. But here we use thread, or specifically extremely strong fibers, to make strong materials and objects. Here, we have some samples.
Wow.
Oh, it's really thin. What is it?
So these are carbon fibers. They started out as plastic fibers, but after baking them at over 1000 degrees, they turned into carbon fibers much stronger than before.
How strong is that exactly, compared to, say, spider silk?
So spider silk is one of the strongest natural materials on Earth, but a carbon fiber here for the same weight would be able to hold twice the amount of load that a spider silk can hold.
Stronger than spider silk. Whoa.
Yeah, so let us show you how we use them.
Okay. This.
Oh, it's thinner than my head. This is so cool.
So this is our braiding machine, which is the first step in turning all these tiny fibers into strong materials.
How do you turn such thin fibers into such strong materials?
So really thin industrial fibers are set into this machine, and it will be braided around a mold, which in this case is the pole we see there. After the braiding is done, the mold will be taken out and resin will be infused into the braided product. After the resin hardens, we'll have a strong material called carbon fiber composite.
So it's like spider silk being braided together.
Except it's stronger than spider silk.
Let's see it in action, shall we?
Let's take it for a spin!
Spin? Really?
Oh my god! Oh my god! Oh my god! Look! It's like it's spinning! It's so wet!
Oh my gosh.
Oh.
Look at how fast it's going. It's like...
Oh my god.
So the braiding wraps the fibers round and round, forming a single fabric. The fabric is the same size as the object, so the load is evenly distributed.
So what's happening is like many different fibers are being combined to form one single fabric.
Exactly, and this makes it stronger. You see, one yarn over here contains 12,000 filaments, and this yarn can hold at least 10 kg. So over here, we actually have 128 yarns, so you can imagine how much force it's able to take. However, this would only work if we align all of the fibers in the correct direction. Because you see, even though it's quite strong here, it actually frays quite easily in this direction.
The braiding machine works like spiders. Spider silk is produced by spinnerets, complex structures made up of microscopic spigots that don't just produce one single thread, but many individual strands. Each fiber is made up of a blend of stringy and stiff polymers. By combining these strands together, the spider silk and its web structures become strong. The fibers that Jing Han and Janelle worked with are strong lengthwise, but don't have the same stretchiness and strength as spider silk sideways. So by using the braiding machines, they braid these fibers such that the strength of the fiber is shared in more than just one direction. One yarn contains 12,000 strands and can hold at least 10 kilograms. By braiding over 128 yarns together, they create a composite that can bear loads in any direction. And all the yarns are doing their fair share, so you can imagine how much force they can bear.
Exactly. And for this particular object, we actually designed it to be strong in twist. So you can see the white yarn over there spiraling around. In any other directions, it may warp very easily. And I have something to show you guys. Follow me.
Here, try these.
Thank you. Wow, compared to our clothes, these are really strong.
And now let's find out how strong. So this paint can here is about 11 kgs, which you would think is really heavy, but the fibre will be able to take it just fine.
Whoa! That's pretty strong for what was just very thin fibre. So if I were to be Spider-Man, I would arrange my web in one direction so that it is stronger. It's called directional strength.
Makes sense.
Yeah, but there's still one more step. So if we were to add the resin to the fibre, we get our composite. So the fibre makes it strong, the resin makes it rigid, and now we can use them to make other things.
The composite is prepped with plastic and a mesh lining to help the resin spread later on. That seals down nice and tight and air is vacuumed out through the pipes. Careful to smooth out any kinks. With the air out, the resin is slowly added in. The pipes are removed and the composite is placed in an oven to be cooked at really high temperatures. Finally, the composite is done and it's all strong and hard.
And after we wait for the resin to harden, we'll have a variety of products like this face mask, this phone cover, this aerofoil shape, or even this bridge.
Wow.
Wow, all these made from tiny fibers. Cool, right, Dr. K? Ahem.
Oh, yes.
Anyways, thank you so much, Jinghan and Janelle, for showing us all these today.
Yes, thank you so much for showing us this awesome braiding machine. It was really cool.
Really? Like, really?
Anyhow, thank you so much.
Thank you.
Thank you
Thanks
so
for
much.
coming.
Thank you.
Bye.
Still, Dr. K. Really?
We'll get it up next. Now, are there any spiders?
Nope, not at all.
Really? And hey! Okay. Now, are there any spiders?
Nope, not at all.
Really? Okay, I trust you.
Today, we're gonna make our very own wrist-mounted web shooter.
Woohoo! I see you've got some toilet paper rolls cut down on one side.
You need about 3.
And we have some tape, some ice cream sticks, some tools, and a hot glue gun.
Always be careful of a glue gun. Always have a parent around or an adult to witness your event.
And lastly, we've got some silly string over here. Silly like you. Silly like me.
So let's stick the 2 toilet rolls together.
So you get something like this. What it does is that it allows it to adjust to the size of your wrist. Next, we're gonna take out the nozzle from the silly can, just like that. We're just gonna make a hole in the top of the nozzle, go like this.
Remember, kids, don't try this at home without an adult around. You don't want to hurt yourself, right?
So now we're just gonna use a hot glue gun to seal up the hole in the side of the nozzle.
Now, we are attach this to a bottle cap. But poke a hole in the bottle cap so you have a tiny hole and you can shoot it straight. So now attach them together and you have something like this. So now we'll attach the bottle cap, which has been glued, to the silly string can. And it can shoot straight. See?
Oh! Next, we have to find a way to press this nozzle down using ice cream sticks.
So we'll break it in half and stick it together. So we'll have something like this. And we'll use the flat part to push down the cap.
Next, we're gonna stick a third toilet roll to our wristband toilet roll thingy, just like that.
We'll place this into the holding thing.
That looks pretty cool.
But we aren't done yet.
That's right, we need to complete the firing mechanism.
Okay, so now we attach to the bottle cap of what we had just made and we'll put it like this.
And voila!
If I press this down, this should work. I think we're ready, Kay.
Let's try it out. And the super helpers help me to make this. Ooh. Give me a target.
Okay, so what about this?
Perfect. Now, Mr. Danger, we've found out about your entanglements with the law.
Entanglements, like strings,
You've been a little too tied up with crime.
tied up, like strings.
You're caught in your web of deceit and lies.
Just get it over and done with.
Okay.
Too many puns.
Okay, okay. And hey,
Right.
come on.
Let me try.
Wow, you're quite the natural.
I can't see. I learned it from the web.
Hey, did you just? That's pretty funny.
There's another successful build. High five.
Oh.
E.G. What? Ah! Guys! Not funny. That spider looked really big from that angle.
Sorry, E.G. We saw you were sleeping and we thought we'd just have some fun.
Did you guys just get back from the museum?
Well, we kind of sidetracked a little bit.
Long story short, we met a little robotic spider called Scorpio who could actually climb walls and roll around.
And we saw a marvelous braiding machine that used fiber stronger than spider silk to make super hard materials.
And we even made our own web shooter. But
None of it had anything to do with being bitten by a spider. I doubt it really works that way in real life.
Ah well, too bad. It's so great not to be held back by real-world physics. Whoa, hang on. My spidey senses are tingling.
E.G., what are you doing?
Hang on. Aha! I found this little guy hiding inside your jacket.
So now,
sorry! Balik itchy.